So I'll be going through certain points which are helpful in your production workflows and some general mistakes which we come across artist files and which are not well suited for the production workflow. So let's begin with that. Right now I have a PPT where I'll just go through the main points which we'll be discussing on. So yeah, here we go. So generally when we get something assigned to ourselves, what we have to do before starting the modeling process is visualizing. So when we get something, we first need to visualize it. So there are some certain points, we'll go through those. When you have a task assigned, it's not necessary that you start modeling it straight away. You need to ask questions to yourself and get answers for them. You need to gather enough information of the asset. For example, the shot context, the level of detail required, whether it will be rigged or not. So the more information you gather of your asset, the more you will be able to relate to it, the more you will be able to study. The more you know of the asset, the more you can add actual information on the asset which is relatable to it. Then the next step is very necessary is reference materials as well. So once you have all your questions answered to yourself, once you have data collected, that is when you go and start your planning. The planning. So what you have to do planning is of what needs to be done first. So when you get an asset, it's huge asset. So you will be lost looking at, consider if you got a spaceship, what will you do with it? Which area you will begin to do? So such things are the ones which need to run in your mind first. So it's like what needs to be done first, how much time do you have, and how to achieve it with the expected quality in the given time. So these are the things which will come under your planning process. So you need to see like how big it is and what are the areas which I can start first and get the overall look. Yeah, these are the two things which you always have to go through before even starting your model. Then comes the step of reference collection. So when you have to do any asset, maybe the show is giving you, maybe your client is giving you, you have enough references. What you need to do is study the references, make sure you have enough angles so that you can read all the angles from all the different areas. So this is one of the example of the mood board. It's always good to create mood board where you have different angles of different perspectives. If you have different lighting conditions, that is also good. So the software I use and I prefer to create mood boards are PureRef. So PureRef is a good software to do it. You'll be able to collect them. You'll also be able to zoom in on a particular image and rotate or whatever, all that sort of stuff. So I would suggest you to use PureRef for gathering enough materials. Great. So we have the materials. We have all our basic questions answered to ourselves. Then we step to blocking stage. So when we start an asset, it's necessary that we do it in a basic way. So let's go through the points what you have noted down here. Blocking consists of all big shapes. Match the silhouette of the concept art or the reference. Blocking is where you get to know the overall shape, also helps to get approvals, and you will also get an idea of where you can add details and ignore certain areas, considering the visibility. That means if you have a big sketch or a big concept given to you, if you jump on a certain area, consider if you have a spaceship, you have just an exhaust system or a landing gear or the front windshield. You can't get stuck to certain area and keep on adding details on that. Like that, you will not be able to get an overall look. You'll not be able to know if you're going in the right direction. So what I would suggest is get the overall blocking, whatever looks big. Try to zoom out your camera as far as you can and see from that distance, what do you see? Try to block out those areas so that you get an overall silhouette of the asset. You'll get overall idea of it. When you present it to someone or when you look at yourself, you will have a very clean and a good idea of whether it's going right direction or something is going wrong. So always start with blocking. What would you do to attain maximum shape of a huge asset? That is when we reuse to maximize our speed. When we model any gigantic model, every element will not be unique. Consider a spaceship, it will have multiple doors, and all those doors necessarily don't mean to be unique. Almost like 80% of the doors will be similar. So what you have to do, study those, visualize those, and see what place can be reused multiple times. So build one asset, one door or a one frame, make sure that asset is very well, it has no issues, then you can reuse it, duplicate it a number of times, and make use of the time. So that is reusing an asset which already exists in your concept. Also, one of the major thing what we do in huge assets is kit bashing. What is kit bashing? Kit bashing, maybe some are familiar, some are not. Kit bashing is basically a library of objects or assets which are pre-done. You can use all those, pile those up together, gather and place them, scale them, rotate them, and get an overall look of an asset. If you have no time and you have to present any concept to someone, that is when kit bashing plays a major role. So, for example, as I have written here, the creating rivets, pipes, and generic objects again and again is all a waste of your time. So, such things you should already have made them and stored them. Consider rivets, any objects, any vehicle. You'll have a lot of doors, handles, such things. You need to make a library of them. Make sure they are good. They hold enough details when you go close up. Keep them as a good quality library and reuse them as much as you can. Cool. Let's move to the next point. Yeah. So here, we were going to discuss about some topologies. So when do we say bad topology, good topology, bevels? It's it's not that topology is a very critical thing. It is critical if an object is going to be rigged and if the surface is going to be soft. So let's go through the bad topology points here. Bad topology is occurred when you do not plan your asset in prior. You don't plan your asset, you don't know where you have to add details. You straight away, without studying the basic shapes, you'll go and keep on adding, throwing lines. Consider you have a huge plan and you have to do a certain hole in certain small area. You will drop in a number of lines there and create that particular circle in a perfect shape. But what would that result in? That would result in multiple edge loops, which will be much harder to solve in when your asset grows. This is how the bad topology will try and start troubling you in the long run. One more issue with bad topologies is when you leave your five-sided edges and triangles on a curved surfaces. At times they look good. You will think it has no issues and you can probably ignore them. But when you render them, you will kind of see some artifacts which will eventually not look good. How would you achieve good topology is if you aim for a better and lesser topology. It helps you to manage and get basic design locked. Once that is done, it'll also help you while doing UVs. Why am I saying that it'll help you while doing UVs is if you have good topology, you will have proper edge loops flowing according to the shapes, how you require them. So whenever you have to cut them and unwrap them, you just have to select one edge and it will go through a certain design completely. You can select that and detach it in like couple of seconds. If you have a bad topology, imagine you'll click it, you will reach to around 10 to 20 edge loops. Again, there is a deviation where you don't have proper line flowing. You have to manually select that, again continue it. So those are the things which will eat up all your times and you won't be able to achieve your deadlines. Also, n-gons will turn into chords anyways after you smooth them. So when you're modeling something, what I would suggest is you should just start to get the basic look first. When you're trying to get the basic look first, you should just try to keep it in a very low density edge loops and not worry much about triangles and n-gons that time, because that is not important at that certain point of time, and because your topology is also low and you're also attaining your shapes. So once you have met your desired amount of completion of your file and you have time left, that is when you sit and clean up your mesh so that you don't run into issues. Whenever you have leave n-gons, when you smooth and chuck them, they will eventually become quads. So it's always good, if you are planning to ignore an n-gon, it's always good to do a smooth, chuck it, make sure you're not getting a artifact which will be visible from most of the prominent angles. If it's not visible, you can always ignore it. You don't have to put all your valuable time and waste your time on that. Then one more important topic will be bevels in hard surface modeling. So bevels are the most important part of hard surface modeling, as in most scenarios, this is what defines the material of an object and plays a role in making it appear a realistic or computer generated. You can see some assets, when you look at them, you can instantly make out this is a computer generated. It won't look much realistic. It's because most of the edges would be very planned, and the beveling will be done without any thought process. For an example, if I have to talk about a metal pillar or a metal bar, you can think of bridges, right? Bridges are, you'll have a long uh, metal rods. So if you go and just do a basic shape and add a lot of supporting edge loops, your edges are going to look very sharp and crisp. But if you have seen in real life, that is not how sharp the metal rods will be, right? The corners will be pretty soft, and they'll also have certain wear and tear. You can see a slight wobble, a slight dents in there. So you have to introduce all such things in your basic model so that it gives you a pretty realistic look rather than a computer generated look. So those were some things which we had to discuss in theory. Let's get into practical, and let's see some basic model issues which we go through and what are certain things which will help us to keep a model clean. This is the area, which is the basic file which I came across, and this is how I have fixed it. So if you see this is how the original file was, and this is the fixed topology. Let's go. And the reason why he achieved all those additional topology is because he did not solve his edge loops from the inner area, right? And this is how it is solved. You can see the amount of topology which is reduced. Similarly, if you go and check here, even here, there is a lot of dense topology which could be fixed in a simpler way by doing that, right? Why we have to sit and fix all such things is to avoid so many unnecessary edge flows flowing. As these edge loops don't provide any purpose, we have to get rid of them. And what I was explaining was, if you see this particular cube here, the artist has added so many unnecessary loops just to keep this surface crisp and square, right? What he could have done instead is add just 3 loops. That would save all his topological errors, and he would also end up with a much lighter file. One more thing to notice is, yeah, so here the artist has done this particular curvature here. What he has done is he has completely ignored the basic shape. He has just kept one edge, thinking when he presses 3, it'll end up to be a proper curvature. But that would leave this kind of artifacts to that. So the basic process of modeling would be add enough edge loops, which will give you the curvature, right? In model itself, you should be able to see the curvature. So you can see the difference here. So these are the things which you need to take care of when you're modeling a hard surface model. Always try to avoid unnecessary lines, and wherever possible cut the lines flowing. So certain examples of flowing these lines cutting is, the purpose of these lines is only here. We need so much topology only there. We totally don't need them in that area. What you would do in those areas is go ahead, do that. You can easily get rid of those two lines. The similar way you could do this for here also, right? We have no issues in our surface. Surface looks as perfect as it was before, but we have reduced a considerable amount of lines flowing throughout the ship. So these are certain things which we constantly notice in the artist files in the shows. So it's better to keep them as light as possible. So let's be done with this particular boat. Let's move on to some practical examples. One more thing which we see a lot in our files is this kind of topology. Whenever an artist needs cylinder, he would just do it. He would not even think of what's happening here. He would end up adding so many counts which has no purpose, as it's a flat area. And if it's a single object, two objects, it might be enough. You might ignore because your overall file will not be heavy. But certain assets will be such that this kind of objects will be duplicated like 100 of times. And that time, if you end up with this kind of topology, you just imagine how heavy, and it's going to be very heavy. Even you will not be sure why your file is heavy, why the topo count is so high. As they will be hidden like this, you will not even know where they're coming from. So there are two options which you could do, is either delete an alternate edge here, try to keep 5 side, and keep less edges merging to one vertex. Another best option is this one. How would you achieve this is, let's take a cylinder. What I would generally do is reduce the count from 20 to 10, delete an alternate edge, add a supporting loop here and here, and smooth it. You have a cylinder which has much less triangles merging into single vertex. And this would also help you to add edge loops here. One more thing to keep in mind is when you guys add edge loops, and if edge loops are not maintained with a proper distance between your desired edge, you would end up having a not so great bevel. Always guys, add a blend, only then you'll be able to see your surfaces. So due to this edge loop not flowing properly and with equal distance to your edge, we are seeing a deformed bevel here. You can see this is much softer bevel. Here it has got it pinched. So at such points, I would suggest you guys to always go to your edge loop options and keep equal distance from the edge, and drag it from the desired edge you want to maintain it from. That time you will have a equal distance maintained here. You will have an equal bevel without any pinches, right? Cool. So that is one of the major issue we keep on saving in most of the assets. So I would suggest you guys to always make it simple and neat and clean. It will help you in your other design procedures. Cool, that was one. Then I had some certain examples to show you guys of how to add loops and how to plan your asset so that you don't run into unnecessary issues. One of that was keeping your open edges visible, right? So if you go to display polygon, where is it? Border edges, yeah. So when you see a asset like this, you will think your asset is fine, it has no issues, and you will move on. And what will happen when you smooth it? You'll end up seeing such artifacts. So to avoid such things, it's always good to keep your border edges on so that from any distance you see, you'll be able to make out that there is an issue, right? This issue is because the vertices are not merged. As they are merged, you lost that arrow and it smooths without any issues. Right. Let's move to one of the next example. So whenever you have this kind of shape and you want to keep the creases crisp and sharp, what would generally artists do to save up their time is add random lines, right? They add random lines, they achieve the results. If they don't achieve, they would go ahead, add even more lines. Well, they achieved the result, they're happy, and they leave this asset as it is. But what eventually happened is we have so many loops flowing there, which are not necessary. What I do and suggest is this. There is an option in edge loop where you can select your edges, go to insert edge loop, then control shift right click, switch off this autocomplete. Then you can directly add just one line which will add the supporting loops throughout, where you don't have to do 4 to 5 times, right? Just click once, enter. It will also give you the supporting edge which will convert it into four-sided, right? Now you would say that it is still not satisfactory and not sharp. At time what you would do, select your edges, bevel them, increase your segments to 2. It's a curved surface to make it crisp. Off your camphor, now you have a perfect squarish object over there. Delete that edge, connect this, use a connect component, it will merge the relevant vertexes. Then you could also get rid of those lines like that, right? Looks much neater, and you will also achieve your desired. Could also achieve your desired topology, and not even single edge loop is flowing anywhere. And yet, just with this basic setup, you have a great looking corner, right? So you don't have to do these on all the corners as well. We have mirror tools, you can always use them. It's in the plus, let's do it negative. Yeah, now we'll go to next. Just by doing that, we have it on both the sides. Those were two of the steps. Let's go into another example which I was planning of. So one more thing or one more tip is, whenever you have a curved surface and you want to cut a shape in it, uh, don't try to do it manually every time. For example, let's see if this is what we are looking for, right? This is the cut we are looking for. What I would say, if this is how you get a blueprint, what most of the artists would do is they would model till here. For example, they would model till here. After that, they would select edges, extrude, extrude. Then from here, they will want to adjust their loops. What would that do is that will eventually take most of our time, and we might end up with dents and curvature artifacts, and it will eventually take a lot of more time as well. So what I would suggest is, as this is the whole curvature and there is a cut in this curvature, make the whole curvature first. Though you have a line here, make the whole curvature first. After that, you can draw your desired shape. Then you can go ahead and delete it. Right? You can delete it. That will do what that will do is it will maintain your curvature, and it will also have your accurate cuts done. After this, we can always go and solve our topologies. So let's see, we are getting one line here. So we need a line over there. Slide edge tool, which will match it to that point. Select these two. And most of the times I've seen people doing this as well. They'll use multi-cut and connect this. That is good, but there are faster options. Just select these two vertices, shift right click hold, connect components, and you're done with your job. So when we connect anything like this on a curved surface where all the edges are doing the job of making the surface rounder, one additional line has come that would eventually give a sort of pinch over there. And always in hard surface modeling, guys, try to keep a material which spec is a slightly a bit tighter, right? That is when you would see, you can see here as it comes here, it is much more stronger than it flows here. So what you would do that time is, you can see that, right? From here till here, it is becoming straight. So what we could do is, let's try edit edge slow. That always helps. That went all the way up. So that time we will not have any choice. Let's slightly and maintain the curvature. We have a similar example here as well. Vertex selected, connect components. Let's see if you have artifacts. Don't have so much. Yeah. So one more thing, what I would tell you guys is, so what happened in this model is we have our shape, we have a thickness, but when we smooth it, we end up with this this artifacts. Now fixing this would be an issue. Why it's an issue is because it doesn't have a supporting edge loop. So if now at this time, if we plan to add an edge loop, you can see how our topology is flowing. So what at that time we are forced to manually add loops like this, and that might eventually cause pinching because as we add them manually, we might not be able to maintain equidistance. So what I would suggest at this part of the time is, do we have a duplicate? No, we don't. So I'm okay. Let's ignore this. What I would say is, in case we have another plan of cutting something like this, bevel it up, increase your segments. Any edge solving is there, you can do it from the last edge. What happens is, eventually we will be deleting this. We will also have supporting loops flowing throughout at a equidistance. Then when we solve these edges, we can easily avoid such pinches or indentations which will be occurring. And in the hard surface modeling, don't try to select an edge and merge to center. That would pull both the edges to a different position. So what you should be doing instead is, if you are precise that this is the line where you want it to be, you don't want to mess with this line, always select the another vertex which you want to move, merge vertex, target weld tool, move the other edge to the desired edge so that you don't have any jump from that particular area. Now if you plan to extrude this one, always make sure you check your normals. As you see, we have enough supporting loops. We are very free to add desired edge loops there to make that edge much more sharper. When we smooth, we don't see any that sort of pinching which we were seeing here, right? So this is much more sharper and neater than this. Those are some of the cutting a curved surface. Whenever you're cutting some curved surfaces, this is how you have to cut them. Attain the curvature first, then cut it. These things can come handy when you guys are making a car bumper, I would say. The whole curvature of the car bumper is much more curvier. Then there will be headlights and some fog lamp holes. So if you straight away start modeling the fog lamp holes from the plane, you will end up having a lot of dents and curvature issues. So make the whole curvature like a blocking kind of a shape. Then anyways you will have blueprint. Just draw a cut edge on top of that, then extrude it and delete it. You will have your curvature very well maintained. So these were certain examples. Let's close that as well. Then there is a very common mistake which people do. Uh, let's go to UV set editor. Sorry, UV editor. Yeah. So these are our UVs, and sometimes when they need supporting loops for a squarer object, people will do beveling. Bevel in it like that. So that is the general issue which they would ignore, because if it's a smaller object, these things will not be visible and will end up ignoring such UVs. So the best way to fix those is just increase your segment to 2, right? That time you have a very well maintained corner also, and you'll never have to worry about your UVs when you do beveling, right? I hope you guys saw the difference in that. Cool. Those are certain examples. Now let's try to do some very simple hard surface model where we will end up using uh, the techniques I told you guys. There is another thing which I missed to tell is about creases. Whenever you guys are doing hard surface modeling, it's always good to use creases. Let's say we are making a screwdriver kind of a thing here. Extrude that. We add an edge loop. Right, let's call it before adding that edge loop, we can finalize the thickness we require. That be that, right? Let's apply our trusty plain material. Now that's the shape we eventually got. But to make this certain area sharper and this area rounder will be an issue for us, because only this area will be sharp in screwdriver and the whole pipe will be cylindrical. So what would you generally think of in the first passes? Let's add something like this, then try to solve the issue. But what would that do is create a overall square object. So instead of doing that, you can select your desired edges, mesh tool, crease it, right? And press 3. And if you slide your cursor with middle mouse, the weight of those edges will be sharper, right? Then we can just add edge loop here. Then we would attain a cylindrical object. As you can see here, it's getting rounder. We can add crease to that as well. Equals crease. And let's see, when you drag this, if you notice in the bottom corner of the here, you could see the strength of it, crease value. It will go from 1 to 10. So if you see from before to now is, it's much straighter. We have a crisp angle and also a cylindrical object, right? So we'll try to model something using these techniques. Let's go to a plane. Let's reduce the count a bit. And we have the symmetrical tools, so let's always try to use them, which will speed up our process. So let's say, make this a bit softer, rotate it. And then one more tool which some might be aware, some might not be aware is if you want to move this vertex along this edge, you don't have to use this and ruin your shape. You could use Control Shift, no clicking of any button. You just have to slide your cursor and it will run through the edge loop of the desired edge, right? Then we can pull this out. Let's pull this out. It's good surface. Let's bend it slightly. Let's extrude that. Smooth this. One more thing, guys, when you guys are using symmetry, right? If you guys use edge loop, it works. Sometimes it doesn't work. Sometimes your edge loop doesn't work. Uh, yeah, it's working. So sometimes it doesn't work. That time you guys can use multi-cut tool. Okay. So again, we have missed adding our blend tool here. Due to that, we are not able to see the curvature. So we go and add our blend tool. Let's get this down. Add another edge loop. And also move your edges with Control Shift. It will slide over your existing edge. So let's say we are trying to attain some shapes, some sci-fi kind of hard surface shapes. As you can see, the topology count is way too low here, but we're still managing to get certain desired shapes. So one more thing which you guys have to learn in hard surface is snapping tools. Always try to use tools as much as you can which is available in the software. That is what will help you to speed up your modeling procedure. So let's say if I have to match this vertex to this point, I don't have to manually do that. Neither I have to go to top angle and do that. Just just press V on your tool and use your move key, right? I'm holding V on my keyboard and just using my move key, and it will perfectly snap. Because we are using symmetry, it's happening on both the sides. So these are the things which you guys have to keep in mind to attain quicker results and not to be a amateur modeler. So let's have some shapes. Cool. As I was telling, first to attain your curvature, once we have a nice curvature, what we can do now is I'm planning to cut this thing to have a desired shape. So I'm using multi-cut. So I'll do that and I'll store it like that. I'm planning to delete this edge now. You can see that I have a properly flowing object and also a supporting material which is completely intact with the shape. So, so that looks good. Let's say I'm pretty okay with this shape, and I want to, right now you have very less topology, but if you want to add any further details, you are in need of extra topology. So you don't have to manually go and keep on adding your topologies. That would that would cause you certain time consumption and all. So what I would suggest is select your key ingredients. Like if you want these edges to be sharp, select those. Let's say I want that to be sharp and this to be sharp. What you could do is use your crease tool. Mesh tools, crease, right? I'm increasing the value. Cool. So now I have some sharper, sharper shape. Probably we can include this edge as well. Mesh tools, crease. Yeah. Now I'm happy with the shape. Now what you can do is go ahead and smooth it. You see what happened? You have much denser mesh now, very well divided, very equidistant topology. You have, you can see that it's so perfect, and you have more topology now to add more details. If you don't wish to see crease, you can just go to this one and hide your crease edges. So cool. So we are running out of time. So these are some of the basic tips what we had. Uh, Let me show you just a couple of things. One more thing which I wanted to show you. Extrude this edge. So let's say we want to make some kind of pipes or something coming out of this place to the bottom area. What would I do is create a cylinder. Let's say this is our pipe or some kind of structure. Let's give it the desired length we are looking for. Let's see that's the length we want. Then we'll increase its count. Let's make it height for around 25. It also will do, because whenever you're planning to bend something, it's better if it has more topology. Okay. Now we want that pipe to come out from this area and connect somewhere to the bottom. What would we do is create curve tools, CV curve tool, keep your wireframe on with the V on your key, done that, V on your keyboard, click on one vertex, V here, V here, V here. Let's do one more, V here. Cool. Now we have control of our topology, curvature. Let's see, that is how we want one or a couple of the pipes to pass. So that is how we can shape it however we want. Then select the curve, select the topology, deform. Uh, why do I not see it? we should have been a tool called as a curve wrap here. If you just hit on that tool, this particular design would come and stick to this particular shape. Then also you will have multiple options in that of controlling the thickness and also the movement of the topology which you have used. No worries, we don't see that tool. It doesn't mean we can't do it. We can always have any cylinder. Snap there. Detach. The thickness of this would the thickness of that would matter according to the cylinder which you guys selected. So you can change the size of the cylinder and also create certain tubular structures like that, right? Cool.